Okay, number one, which equation best describes the line? So a lot of times, this is just some general test taking strategy. I will look at the multiple choice answers just to get a feel for what I'm even looking for. So these are all written, they have the y solved for, they're all in slope-intercept form. And so apparently I have a line over here that I'm going to be looking at in slope-intercept form. And before I even look at the line, look at this. They all have -7, so I'm assuming the y-intercept over here is -7, and if you look at it, it is. So that's helpful. So really, what are we asking here? We're asking, hey, what's the slope on this line, right? These slopes are all different here. And so is the slope -2/7? Is it -7/2? Is it 2/7? Is it 7/2? So let's come over to our line here. We're going to need to grab a couple points in order to be able to tell what the slope is. You can grab any points you want off the line. I recommend grabbing points that are right on the corners on whole numbers, like this one right here at 0, -7. That's kind of helpful. And then you could probably grab like maybe that point right there. I'm going to grab this point right here. I think the idea on this is that they have the x-intercept right there at 2, 0. So we've got those 2 points. And now the question is, what is the slope between those 2 points? So how much do we have to go up and how much do we have to go over? Well, we got to go up 7/2. So up 7/2. That means our slope is 7/2. And so that means that this is our answer. Whoa, that's not what I wanted. Why are we doing this? Oh, because it's a highlighter. All right, let's move on to the next problem here. Number 2, determine which of the following ordered pairs is a solution to the system of equations. So what I would do here is you can either solve this problem or you can just start plugging answers in. Like if you want, you could take these answers of 2 for x and 4 for y and plug them in and see if they actually work for both. I'm slightly more inclined to do that. So if you do 5 times x plus 4 times y, the question is that actually -30? And that would be no, so it's clearly not going to be A. So that's one potential way to do it. I think just for the sake of actually solving out the problem, we can just solve this. So if I was going to solve this problem, let's see, what would I do? I would probably do, elimination. And here's what I would do. My goal would be to get rid of the x's. So I would, if it was me, I would multiply this by 3. So I'm going to get both of these x's up to 15x. Okay, so 5x and 3x, I'm going to get both of them up to 15x. I would then multiply this one. I'm going to multiply this one by -5 because I want to get a positive 15x up here, and I want to get a negative 15x down here. So let's go ahead and do that. So if we write this one over here, you'll get 15x plus 12y. Don't forget, you got to distribute that 3. That 3 needs to go to everything. So that's going to be equal to -90, and then negative 15x down here plus 45y, and that's going to be equal to positive 90. Okay, so we're going to take these equations and then we're going to add them together. So when we add them together, we get 0x, so I'm not going to write anything there. We get 57y, and that's equal to 0. I got a little worried there. I was like, whoa, 57. That's not going to work out well. So I'm going to divide by 57, and you get y is equal to 0, because 0 divided by 57 is 0. Okay? So if y is 0, then we could go back in and plug and solve for x. I know now that this cannot be an answer because the y value is not 0. So it's either -6 for x or 0 for x. So let's just take one of our equations. I'm just going to take this first one here. And we'll come in and we'll do 5x plus 4y is equal to -30. So 5x plus 4y is equal to -30. And if the y value is 0, then the question is, what's the x value? So I'm just going to plug in a 0 where that y was. And then we have 5x plus 4 times 0 is 0. So basically 5x is equal to -30. So I would divide by 5. and then I would get x is equal to negative 6. So I think that was option choice B, right? Yeah, so negative 6. All right, so that would be our answer for that one. All right, number 3, which equation best represents the graph? So what I would do here, again, is I would take a quick glance at the graph. So I've got some shading here. Looks like an inequality. And so they've put all of these in slope-intercept form for me. That's kind of convenient. It looks to me like this is shaded below. So what I'm going to do is I'm going to actually kind of come over here and write out this line. So it's going to be y is less than or equal to, because it's got a solid line here on the edge. It's not a dashed line. And then let's see. So what's our y-intercept here? So our y-intercept to me looks like negative 2. And then what's our slope? So we're going to have something times x. Let's see. All right. So we're going to go from this point to the green point. We have to go, let's see, we have to go up 3 and we have to go left 4. So up 3, left 4 would be our slope there. So 3 over negative 4x minus 2. You can rewrite this as y is less than negative 3 over 4x minus 2, which would be option B right there. All right, moving on to number 4 here. Find the slope of the line shown in the graph. Remember, slope, all you need for slope is you need to just pick 2 points that are for sure on the line. So I would say, I think this point's a pretty good point to pick. I'm going to zoom in here on this a little bit. And it looks to me like we're kind of roughly going up. Like, it's not quite exactly on there, but I think it's close enough. It looks to me like we're going up 1, right 2. Down 1, left 2. So I'm just going to say, yeah, I'm going to say that we're going up 1, right 2. So I would say B for this one. Okay, all right, how about number 3? Just kidding. Number 5, that's a typo. All right, which equation is represented by the graph below? Again, we just got a slope-intercept here. So our intercept here is 4. So I'm going to build this. So y is equal to something plus 4, and then we just need the slope. So what is our slope to get from here, this green point, up to the blue point? So we have to go, I'm going to say we go up 4, and then we go right 2. So up 4, right 2. So 4 over 2x plus 4. Don't think that is an answer over here, so we're going to have to simplify this a little bit. So what's 4 divided by 2 here? So 4 divided by 2 is 2. So 2x plus 4 would be your answer for this one. So that's going to be option choice D. All right, number 6. The formula D equals RT represents the distance traveled. Okay, so this is kind of a physics concept here. D is distance, R is the rate, and T is the time. So if you have your rate of speed like 30 miles per hour and you travel for 5 hours, you would go 150 miles. That's how we figure that out. They want you to solve the formula for R. So you have D is equal to R times T, and they want you to solve for R. So imagine if you were trying to get R by itself. What would you do? Well, I would divide both sides by t, because that would get the r alone, right? When you divide by t, t divided by t is just 1, so we just kind of cross it out. Some people say that it cancels. What you've got then is if you have d divided by t, which we don't know what d or t is, so we can't really divide them, right? If it was 8 and 2, we would say 8 divided by 2 is 4, but d divided by t is just d divided by t. Okay? So, and this is it. We've solved for r. So we've got r is all by itself. So r is going to be d divided by t, so that's answer choice C here. Number 7, your neighbor has a rectangular yard with these dimensions. Which expression describes the area of the yard? Okay, so area, remember, area of a rectangle is length times width. In our case, the length is always the longer part of a rectangle. So this right here is 2x minus 3. And the width is x plus 4. So what we're going to do is we're going to take 2x minus 3, and you have to put this in parentheses, times x plus 4. You have to put that in parentheses. One of the most common mistakes that people make is they'll do 2x minus 3, and then they'll write times x plus 4, and then guess what they do? They do 2x minus 3x plus 4, because all they did was they multiplied the negative 3 and the x here, but they didn't actually take the time to think about what this is. So that's a super common mistake. Do not do that. All right. Anyway, we need to actually multiply this out now. So this is called multiplying polynomials. Okay, so we're gonna do 2 times x, and then we're gonna do 2x times x, and then 2x times 4 in the blue. In the green, we're gonna do negative 3 times x, and in the new color, which I'm gonna make like kind of an orange color, that did not turn out as pretty as I hoped it would. We're going to do negative 3 times 4. Okay, so 2x times x there in the red. When you do 2x times x, you get 2x squared. So 2x times x is 2x squared. 2x times 4 in the blue there, that's going to give us 8x. When you do negative 3 times x in the green, that's going to give you negative 3x. And in this weird orangish color, negative 3 times 4 is going to be minus 12. Then you just need to collect like terms. So you have 2x squared. And then how many x's do we have? We have 8x minus 3x. So that's going to be plus 5x. And then you have minus 12. Okay, so that right there would be the area. And what's cool on this, I think it's cool, is if you actually put in numbers here for x, like if you put in 5 for x, you'd get, 2 times 5 is 10 minus 3, so you would get 7, and then you'd get 9 here, which is kind of weird because the length should be longer than the width. But anyway, what happens is if you did 7 times 9, you'd get 63, and if you actually plugged in 5 for x down into this expression, you would also get 63. So 2 times 5 squared would be 2 times 25 is 50. Plus 5 times 5 is 25, so you'd get 75 minus 12 gives you 63. So that's what's cool about algebra, is we can still multiply unknown quantities and get an expression that still shows us that quantity. I just think that's really cool. All right, so what would our answer be here? We want option choice B for this one. All right, let's look at number 8. So they want us to solve the linear system, x minus y is equal to 1, 2x minus 4y is equal to 0. It looks like they gave us a graph. Looks like they gave us a graph here if we want. You could graph this. Honestly, I just think it's easier. Maybe let's multiply this equation by negative 4. Why am I multiplying by negative 4? So the reason I'm multiplying by negative 4 is because my goal is to get the y's to cancel. I guess we could cancel the x's, but I just saw the y's and wanted to cancel the y's. So if you multiply this by negative 4, you're going to get positive 4y here, and then when you add it with negative 4y, they will get rid of each other. So if we multiply everything in here by negative 4, what would we get? We would get negative 4x plus 4y is equal to negative 4 times 1 would be negative 4. Okay, I'm just going to rewrite this second equation here. 2x minus 4y is equal to 0. And then what we're going to do is we're going to take the black equation and add it to the green equation. So what would our result be here? Our result is going to be negative 4x plus 2x would give us negative 2x. 4y minus 4y is 0. You can write 0 if you want, but I'm just going to leave it blank. Negative 4 plus 0 is negative 4. So let's divide by negative 2. And our answer here would be x is negative 4 divided by negative 2 is positive 2. Okay, so x is positive 2. Once we know one of the variables, you can come back to either equation and you can put that variable in and then solve for the other variable. So like we know for sure that x is 2. So what I'm going to do is I'm going to take that first equation, x minus y is equal to 1. I'm going to put a 2 in where the x is. Oh. So literally I'm just going to put a 2 in. So 2 minus y is equal to 1. And if you think about this, if you have 2 minus a number and you get 1, then you must be subtracting 1. But anyway, we can use algebra to solve for this. So if you subtract 2 from both sides, you'll get that negative y is equal to negative 1. So if negative y is equal to negative 1, and you divide by negative 1 on both sides to get rid of the negative there, you'll get y is equal to positive 1. Okay, so y is equal to positive 1, x is equal to 2. That is going to be answer choice B there. How would you know if your answer is correct? Well, you can go back in, and you can plug in 2 for x and 1 for y into both equations and just make sure that it works for both of them. And if you do that, it does. All right, so that's 8. All right, 9, determine the rate of change for the following table. So rate of change is just asking how quickly is our thing changing. And our thing could be anything. It could be temperature, it could be your weight, it could be the cost of something, could be the number of people. So in this case, we're dealing with temperature. And what we've got here is we got a time measurement, and then we have a temperature measurement. So basically, as the time goes on, right, it looks like these are going in 3-hour increments. The temperature goes up. So the temperature is going up as time goes on. So we should have a positive answer for this. Really, I guess my question is, if we go 3 hours, how much has the temperature actually changed to get from -2 to 7? So -2 to 7 is 9 degrees over 3 hours. So this is just slope, right? It's how much are you changing? So you're changing 9 degrees over the course of 3 hours. So 9 degrees over 3 hours works out to be equal to 3 degrees every 1 hour. So we call this 3 degrees per hour. 3 degrees per hour. And we write it like that. The per, I don't know if you guys ever thought about this, the per just means divide. Right? So 3 degrees divided by 1 hour. That's the rate of change there. All right. Number 10, what's the domain of the graph below? Domain is just asking what numbers could we possibly plug into x where we would actually get an output to go with them. So like -2, for example, if you plugged in -2 for x, the output is 0 for y. So -2 is part of the domain. -1 is part of the domain because you get positive 1 as an output for y. If you plug in 0 for x, that's in the domain. How about if you plug in 1 for x? You get 3 for y. And as you start to go along, you start to realize, wait a second, we can plug in anything we want in the domain here, right? Like I could plug in 2, I could plug in 3, I could plug in 4, I could plug in 5. The line goes forever here. So basically what we're saying is we can go forever in that direction, plugging in values for x. We can also go forever in that direction, plugging in values for x. So you can go all the way back to -infinity. You can go all the way up to positive infinity. Okay, so if we were going to give this in interval notation, we would say the domain goes all the way back to -infinity, all the way up to positive infinity. And the way we would say this is all real numbers. That was a terrible job circling that answer, but whatever. All right, 11, we got another rate of change problem. It says the rate of change is consistent. What is the rate of change? So looks to me like what we're doing here is we've got time measured in days. So we move like 1 day at a time on the top of the table. And then the question is how much, so that's 1 day. The question is how much are we moving in the bottom of the table per day? So that would be $25, right? 75 to 100. So it's $25 per day is how we would say that. So $25 per day. So $25 for 1 day. All right, 13, a rock climbing gym charges non-members $16 per day to use the gym and $8 per day for equipment rental. Members pay a yearly fee of $450 for unlimited climbing and $6 per day for equipment rental. I'd be so annoyed if I had to pay $6 per day when I pay $450 a year just to rent equipment. Anyway, okay, which equation, so let's read the question. Which equation could you use to find out how many times a member must use the gym to pay the same amount as a non-member? So what we're going to do, the way that I think about this logically is I think of like, okay, a member is going to pay a certain amount. And then a non-member is going to pay a certain amount. There's a certain place where those things are equal. And so what we're going to do is we're going to write out an expression that could model how much a member would pay based off of the number of times, like the number of days they visit. So what I'm going to do is I'm going to make x a variable. I don't know what x is. X is the number of, how do we want to say this? Number of days we visit. Number of days visited, okay? So that's what x is going to represent. And let's think about the member, okay? If you are a member, members pay a yearly fee of $450, a yearly fee of $450 for unlimited climbing, and $6 per day. So basically, if you are a member, you have to pay $450 once, and you pay that once like at the beginning of the year, okay? Like my wife and I have memberships to our gym, and for whatever reason, ours happens to fall in September because that's when we like joined our gym. So every September, they bill me for it. And I'm like, whoa, what is this? And then I remember, oh, right, it's just our annual membership fee for our gym. So it's $450. You pay that one time. You don't have to pay that like every time you visit, right? You just pay it once every year. And then you have $6 per day. So if you only went once, you would only pay $6. But what if you went twice? Then you would do 6 times 2. What if you went 3 times? Then you would do 6 times 3. What if you went 4 times? You would do 6 times 4. What if you went X times, right? We don't know how many days we visited, so instead of throwing in a number in there, what I'm going to do is I'm going to throw in an X, because I don't know how many times I've visited, but I'm using X to represent that number. Okay, this is kind of the abstract algebraic thinking that we're trying to help you guys develop. So you gotta, I know it's tough to think this way, but you gotta start to learn to think with numbers that you don't know what they are and how they work, right? So you would do 6 times x. That would tell you how much you pay for each day, for all of the days that you happen to go that year. Okay, so that's how much the member pays. That's supposed to be equal to whatever the non-member pays. So the non-member, what's their situation? So they have to pay $16 per day to use the gym, okay, right? So a member just pays $450 once to use the gym, anytime they want, all year, unlimited climbing. The non-member has to pay $16 per day, so every time they show up, they have to pay $16, and $8 per day for equipment rental. So not only does the non-member have to pay $16 every time just to show up to climb, they also have to pay $8 for the equipment. So how would we write that out? How much would it cost a non-member if they went once? Well, it would be 16 times 1 plus 8 times 1. What if they went twice? Well, what happens here is that it would now be 16 times 2 and then 8 times 2, right? That's how much the non-member would pay. What if they went 3 times? It'd be 16 times 3 plus 8 times 3, right? We don't know how many times the non-member goes, so what are we going to do? This is where our algebraic thinking comes into play. We're going to put an x here, and we're going to put an x here. However many times they happen to go that year, number of days visited, right, x, that's how much they're going to pay. Okay, so the non-member is going to pay 16x plus 8x to visit. And let's see, I believe that is one of the answer choices here. So we've got 450 plus 6x is equal to 16x plus 8x. That is going to be option choice D. Okay, so that's how I would do that one. That's a tough, kind of a tough concept to understand. All right, number 14, which of the following relations are functions? So remember, a function is any relation where each input value has exactly one output value that it goes to. Okay, so for example, on this first one, -3 goes to 2. If I look at the rest of the coordinate pairs, the input-output pairs, there better not be any other inputs of -3 that go to a different output. If that happens, then it's not a function. Okay, so let's look through. Do we have any other -3? We have a -3 that goes to a -1. See how you have an input -3 that goes to different outputs? This is not a function here, not a function. Okay, how about the second relation here? So we have a graph, right? The question is this a function? So for it to be a function, you need every input to only get paired up with one output. So like when we have 2 as an input, let's think about this. When we have 2 as an input, what's the output? So when 2 is an input, 0 is the output for y. It's the y value, right? When 3 is an input, what's the output? You've got 1. Now, some people freak out. They're like, oh, but 1 appears as an output twice. That's okay. You just need it so that each input number only has one output number, right? 3 only has one output. 4 only has one output. 0 only has one output. -1 only has one output. So this is a function. This is a function. Because each input value only has one output value. Okay? All right. How about number 3? This is what confuses people. I see a lot of people make a mistake on this one. You've got 2 as an input and 1 as an output. That's great. You have 5 as an input, 1 as an output. That's totally fine. As long as you don't see another 2 or 5 later that goes to a different number, then you're good. You have a function. Now, if I saw a 2 later that went to like -6, that would not be a function because you've got 2 going to 1 and 2 going to -6. That doesn't make sense. You can't have an input go to multiple different outputs. Okay? But as it is written, this right here, this is a function. So this is a function. Is a function. All right, so let's answer our question then. The question is, which of the following relations are functions? So I would say for my answer here, I would say 2 and 3 are functions, but not 1. Okay. For numbers 15 to 17, use the following. F of x is 8x plus minus 4, and g of x is 10x plus 6. So if they want us to add these together, f of x plus g of x, we're just going to take f of x, which is 8x minus 4, and we're going to add g of x to that, which is 10x plus 6. So the question is, how many x's do we have here? We have 8x and 10x. That's 18x. And then we have -4 plus 6 would be plus 2. So that's D there. Next one would be f of x minus g of x. So f of x is 8x minus 4. Really important here that you subtract and then you throw g of x in parentheses. If you don't put the parentheses on this, you're not going to distribute the negative. It's going to be completely wrong. So when we actually distribute this negative, what would we have then? We're going to have 8x minus 4. And then when you do minus times 10x, you're going to have negative 10x. And then when you do negative times positive 6, you're going to get minus 6. So now you have 8x minus 10x. That's going to give you negative 2x. And then you have -4 minus 6. That's going to give you minus 10. So negative 2x minus 10. It's going to give you that one. Okay? F of -2. So what is f of x? F of x is 8x minus 4. And what I'm doing here is I'm color coding because I'm trying to remind you how functions work. Functions take inputs and then they tell you how to get to the output, right? They tell you the relationship between the input and the output. The relationship here is that the input is x. The output is 8 times x minus 4. So if the question is, what's f of -2? We'll put in -2 here as the input. And then f of -2 is going to be 8 times -2 minus 4. And when you do 8 times -2, you'll get -16 minus 4. That's going to give you -20. All right, number 18. How many solutions does this linear system have? So you have x minus 2y is equal to -4. And then y is equal to half x plus 2. So you have several options here. If you want to graph these and figure out where they cross, that would be a solution. If you want to do elimination, you could do that. I'm going to actually do substitution. So it told me that the y value is half x plus 2. So what I'm going to do is instead of y, on this top equation here. Instead of putting in a y, I'm going to put in half x plus 2. So I'm going to zoom in a little bit here. So what do we have? We've got x minus 2y. And I'm going to actually color code this a little differently. So x minus 2 times y must equal negative 4, right? So this is a y right here. I'm going to plug in y, except instead of putting in the letter y, I'm going to actually put in half x plus 2, because that's what y is. So I'm going to put in half x plus 2. And then what we're going to do is we're going to simplify this. So I'm not going to put equals here. I'm going to put an arrow, and I'm going to say, okay, if this up here is true, if x minus 2 times 1 half x plus 2 is equal to negative 4, then x minus, and then what I'm going to do is I'm going to actually multiply. I'm going to distribute this 2 here. I'm not distributing 2, actually. It's actually negative 2. So I'm going to do negative 2 times 1 half x. If you have 2 times 1 half, that's 1. So you're actually going to have, after everything's said and done here, you're going to have minus x for this little part right here. So negative 2 times half x would be minus x. What is negative 2 times positive 2? That's going to give you negative 4. Okay? And supposedly that left side of the equal sign is equal to negative 4. So let's continue trying to solve for x here. So if we combine like terms, if you have x minus x, that's 0. So let's just go away. You're left with negative 4 is equal to negative 4. And now you have this awkward question, right, of what numbers, if I plug them in for x, would make negative 4 equal to negative 4? Which is kind of a weird question, right? We're used to things like this. Like if I had x minus 6 was equal to 12, I would ask you something like, hey, what number, if I plugged it in for x, would make x minus 6 equal to 12? And there's only one answer. It would be 18, right? What's awkward about this situation is that there are no x's. And so the question is, what number, if I plugged it in for x, would make negative 4 equal to negative 4? And the answer is, it doesn't really matter what you plug in for x. Like negative 4 will equal negative 4. And so in these scenarios, what we've got is we actually have an infinite number of x's that we could plug in that would make this true, right? So we say that there are infinitely many solutions for that. All right, 19. Write the equation for a line that has a slope of negative 3. Okay, so the slope is negative 3. I'm just going to write that down. And passes through the point 4, comma 2. Okay, so it goes through the point 4, comma 2. There are a couple ways you could do this. I'm going to briefly talk about both of them, but I'm only going to use one of them. If it was me, just to be 100% sure, I would make a graph. I'd grab some graph paper with an XY axis, and I would just literally drop that point on there, 4, comma 2. So 4, comma 2 is right there. And you know your line has a slope of negative 3, which means what? You're basically going down 3 over 1. Right? So what we're going to do is from that point, we're going to go down 3, right 1, down 3, right 1, down 3, right 1. That's not super helpful, but there are some points on your graph. If you go left 1 up 3, that gets you another point. Left 1 up 3 gets you another point. Left 1 up 3 gets you another point. And then if you go left 1 again and up 3, that gets you all the way over to the y-axis, right? I knew I had to go over 1, 2, 3, 4 because I was at 4 for x, right? 1, 2, 3, 4 gets me over to 0 for the x value. That puts me on the y-axis. So the question is, what's the y value of that green point up there? Like how high is that? And the way that you're going to know how high that is you just know that you went up 3 every time you went over 1. So how much did you climb to get from this point up to this green point? You had to climb 3, 6, 9, 12 to get there. So you had to climb 12. You were already at a y value of 2 there. So if you were at a y value of 2 and you had to climb 12, I guess you'd be at 14. Right, so you know that point there is at 0, comma 14. So then you could just say, look, y must equal negative 3x plus the y-intercept of 14. That's one option. That's probably the way that makes the most sense to me. Another way that you can solve this problem is to use point-slope form, right? So point-slope form is y minus some y coordinate is equal to the slope times x minus some x coordinate. And what we're going to do is we're just going to plug in We know the slope, right? The slope goes right here. We know the slope's -3. Told us that. So we're just going to plug -3 in there. And then what we're going to do is we're going to take an x, y coordinate pair, and we're going to plug in the x here and the y here. So if you plug in, and let's just take this point they gave us here. You could use any point on here that we graphed, but let's just use the point they gave us. So just for the sake of simplicity. So we know the x value is 4, so we're going to plug in a 4 there, and we know the y value is 2. And we already know the slope is -3, so we're going to plug that in. So now we've got an equation of a line in point-slope form, and you can just solve for y now. You can get it in slope-intercept form by just getting the y all by itself. So if you do that, you have y minus 2 is equal to -3 times x. That's -3x. And then don't forget to distribute the -3 to the 4 as well. To the -4, rather. So -3 times -4 is going to be positive plus 12. So now we're here. I would add 2 to both sides. And what you get is y is equal to -3x plus 14. Oh, hey, look at that. That is the exact same answer that we got above up here. Same answer. Okay, so -3x plus 14 will be our answer for this one. All right. Find the slope of the line that passes through the points -5, 8 and -5, -2. Again, I would use the graph paper on this. It's kind of hard for me to envision slope if I can't visualize the points. So they're saying -5, 8. So let's go -5, 8 is roughly up here. So -5, 8. And then, so that's that point. And then the green point here is going to be at -5, -2. So -5, -2 is going to be right here. So -5, -2. They just want to know the slope of this line, right? So there's a line that connects these two points here. What is the slope? So, well, let's do rise over run. So how much are we going up? So we're going up, we got to get from -2 all the way up to 8. So we're going to go up 10. So we're going up 10. And then how much are we going over? Well, to get from -5 to -5, we're not going over at all. So we're actually going over 0. So what's 10 divided by 0? If you plug that into your calculator freaks out. It'll probably say like domain error or divide by 0 error. You can't actually divide by 0. So in mathematics, we call this undefined. So we would say that that slope there is undefined. It is not 0, by the way. 10 divided by 0 is not 0. It's undefined. All right, number 21. Which expression is equivalent to 7x cubed times 6x cubed minus 10x plus 5? We did not spend a lot of time talking about how to multiply these, but I'll walk you guys through this real quick. You're going to distribute this so that we get everything multiplied here. So we're going to do 7x cubed times 6x cubed, 7x cubed times -10x, and then we're going to do 7x cubed times positive 5. When you do the orange multiplication here, you're going to get 7 times 6 is 42. Then you're going to get x cubed times x cubed. I want you to think about this. If you have x cubed, that would be x times x times x. And you multiply that by x cubed, which is x times x times x. How many x's do you have there? You really have 6, so that would be x to the 6th power. So x cubed times x cubed is x to the 6th. What if you had 7x cubed times -10x? What's that going to be? That's going to be -70. And then if you have x cubed times x, that would be x to the 4, because you're going to have 4 of them. And then this last part in green here, we're going to have plus 35x cubed. So that would be your final expression there. So that would match up with this guy right here. All right. 22, if f of x is equal to x squared minus 4x plus 3, they want you to find the value of f of -3. So f of x, so what does f of x tell us to do? F of x says to take x and square it. So we're going to take the input and square it, and then we're going to subtract 4 of the input. And then we're going to add 3. So what if we happened to do this specifically with -3 as our input? So instead of the red x, we're going to use the blue -3 as our input. Well, you just follow the same rules. We're going to square it, subtract 4 of it, and then add 3. Except instead of x, I'm just going to throw in a -3 where the x was. Okay, so what is this? -3 squared would be +9. -4 times -3 would be +12. And then +3 would just be +3. So what is that? 24? All right, moving right along. 23, solve 4 minus x is equal to -5. So I'm just going to write this one over here. 4 minus x is equal to -5. So if it was me, I would subtract 4 on both sides here. When you subtract 4, you get, that's 0. So you get -x is equal to -9. And if -x is equal to -9, you could divide by -1, and you would get that x is equal to -9 over -1 is +9. So x is +9 for that one. All right, 24. Solve the equation for y. 18x plus 4y is equal to 2 times x minus 4. I'm just going to rewrite it over here and work it out over here. All right, 18x plus 4y is equal to, I'm going to distribute this here. So 2x, 2 times x is 2x. 2 times -4 is -8. And the goal here is to solve for y. So what you should do here is you should, whatever you do, it should be based off of the fact that you're trying to get this y by itself. So the first thing I would recommend is subtract 18x from both sides. So subtract 18x from both sides. When you do that, you get 4y is equal to -16x minus 8. And then if the goal is to get y by itself here, you should divide by 4. Make sure you divide everything by 4. So when you do that, you get y is equal to, all right, -16x over 4 is -4x. And then -8 over 4 is -2. So -4x minus 2 is y. So that's answer choice A there. 25. Given the equation of a line, that's point slope form, by the way, right there. Which equation represents the line in slope intercept form? So all you have to do on this is go ahead and actually get the y all by itself here and figure out what it is in slope intercept form. So, all right, so we have y minus 3 is equal to 3/5 x plus 2. So that is y minus 3 is equal to, what I'm going to do is I'm going to distribute this. Okay, so we're going to do 3/5 x, that's 3/5 x. And then what is 3/5 times 2? Do not use your calculator on this. You need to actually know how to do these fractions here. Okay, so 3/5 times 2. All you're going to do is multiply 3 times 2. That's 6/5. So this is going to be 6 over 5. That's 3/5 times 2. Okay? Now, we got to solve for y. So we're going to add 3 here. So what we've got is y is equal to 3/5 x. And then we've got plus 6/5 plus 3. So plus 6/5 plus 3. This I would write as y is equal to 3/5 x. And then what we're going to do is we're going to do plus 6/5. And then we're going to change 3 now. This is how you add fractions. We're going to change 3 so that it's some number of fifths, right? So like for me to actually be able to add these things, I need them to both have a denominator of 5. So how many fifths is 3 then, right? So 3 is some number of fifths. Well, it's 15 over 5 because that's what 3 is, 15 over 5. Okay, so from here we've got y is equal to 3/5 x. And then if you have 6/5 and 15/5 and you add them together, you would have 21/5. That would be your answer for whatever number that was, 25. All right, so that's going to be this guy right here. That's in slope-intercept form. All right. Given the equation of a line 2x minus 3y is equal to -18, what are the x and y intercepts? Well, you can graph this on graph paper, but the trick on this is to realize that the x and y intercepts occur when I'm going to draw a rough sketch of this line for you. So let's see, this line is going to look roughly like this. Okay? And so what happens here is you've got a couple of intercepts. You have the y-intercept right here in blue. I don't know what the y-intercept is, but I do know that the x-coordinate here is 0. And that's the essential part of the intercept argument, right, is that the x-coordinate here is 0. I don't know what the y is. We're going to figure that out, but I know the x-coordinate is 0. And then for the x-intercept down here, this green point, I don't know what the x-coordinate is, but I know that the y-coordinate of this point right here is 0. Like this is where y is 0, and this is where x is 0 right here. Okay, so what we're going to do is we're just going to give each variable a turn being 0. So like for the blue one up here, to find that blue point, we have 2x minus 3y is equal to negative 18. And what we're going to do is instead of x, we're just going to plug in a 0 where the x goes. So 2x minus 3y is equal to negative 18. And what is this? This is negative 3y, right, because this is 0, is equal to negative 18. And then if you divide by negative 3, right, trying to solve for y here, then you'll get that y is negative 18 over negative 3 is 6. Okay, so the y-coordinate there is 6. That's the y-intercept. The x-intercept is the same idea, so we're going to take the same equation, 2x minus 3y is equal to negative 18, except on this one, what do we know? We know that the y value for this point is 0. The y value is 0. So we're going to put in 0 where the y is. So 2x minus 3 times 0, because we know the y value is 0. And then we've got 2x is equal to negative 18. So divide by 2. X is negative 9. So that right there is negative 9. Okay, so what you've got here is you've got your two intercepts, and if you have 2 points on the line, you can actually draw the line now. So they don't want us to draw the line, but I was just showing you visually what's going on here. What would the answer be here? So we need negative 9 comma 0 and 0 comma 6. So I believe that's answer choice B there. '27, which expression is equivalent to that whole mess there? So, all right, here's what I would do. Since you have subtraction, I would just rewrite this polynomial right here. So x to the 4th plus 3x squared minus 5x minus 7. I'd leave that alone. What we're going to do here is we're going to distribute this negative to everything inside of here. So it needs to multiply the 4x squared. It needs to multiply the negative 8x to the 4th. It needs to multiply the 2x, and it needs to multiply the negative 6. So what we're going to do is we're just going to rewrite this now. This second polynomial I'm going to do in red. So it's going to be minus 4x squared. If you have a negative times a negative here, it's going to give you plus 8x to the 4th. Then it's going to give you minus 2x, and then it's going to give you plus 6. If you want a nice little trick, if you just change the sign that's in front of the term, that's how I do it. So notice how this one was positive 4x squared became negative 8x to the 4th became positive 8x to the 4th. Nice little trick there. All right. So let's do this in standard form here. So how many, I think x to the 4th is the highest degree that we have here, right? So how many x to the 4th do we have? We have 1x to the 4th plus 8x to the 4th. So we have 9x to the 4th. How many x cubes do we have? I don't see any x cubes. How many x squareds? We have 3x squared minus 4x squared. So that's going to be minus 1x squared. How many x's do we have? Negative 5x minus 2x. That's minus 7x. And then we have negative 7 plus 6. That's going to be minus 1. So that's your answer there. It looks like that is option choice B. All right. Joe wants to rent a truck to complete a gardening project. He pays $25 initial rent fee plus $5 per hour. Man, that would be fantastic. If you ever go to Home Depot and you try to rent stuff, it is so expensive. All right. Which equation best models this situation? So the cost is going to be a one-time fee. So a one-time fee plus your the amount you have to pay for the hourly rental, right? So the one-time fee plus the hourly rental. So if we were going to model this with an equation, like if y was your cost, your one-time fee is the initial rental fee of $25, and then it's going to cost you $5 per hour. So $5 is the rate. The number of hours we don't know, so I'm gonna put an x in there for that. So this is the equation I would use. Okay, they don't have that over there. They have 5x plus 25, but it's the same thing. You just rearrange the order. That's in slope-intercept form. All right, 29. Which of the following is true about the slope of the line on the graph to the right? Okay, so you got a vertical line here. That slope, if you try to pick a couple points on this to figure out the slope, like between maybe this point and just pick a couple random points there, that would be going up 3 over 0. So what's 3 divided by 0? Please do not say 0. That is undefined. All right, 30. Every hour a runner is able to run the same number of miles if on his third hour, so in the third hour of running, he has gone 15 miles, so he's 15 miles from where he started. And in his fifth hour, wow, that's a terrible 5. He's gone 25 miles from where he started at hour 0. What is the rate at which he run? That's just wrong. That should be runs. All right. Okay, so, well, the question is how much distance did we cover and how long did it take us? So I'm going to say we covered 25 minus 15, so that's 10 miles. And how long did it take us? So it took us whatever the difference was between hours 5 and 3, so that's a 2-hour difference. So that means he's covering consistently 10 miles every 2 hours, which would be 5 miles every hour. So 10 divided by 2 is 5. All right, 31. Samantha made this model of the Eiffel Tower. That's impressive. The expression 5x squared plus x minus 4 represents the total height of the tower. The expression 2x squared minus 6 represents the height of the lower section. How tall is the upper section? So the idea here is that the upper section, like this green part right here, is good. You could find that by taking the entire distance, which I'm going to do in red here. You could take the entire distance and subtract the blue part right here, right? So if you took the red minus the blue, that would give you the green. So we're going to do that. We're going to do the red, 5x squared plus x minus 4, and we're going to subtract the blue section, so 2x squared minus 6. And that's going to give us the green. So when we put this together, we're going to get 5x squared plus x minus 4. And then what I'm going to do is now I'm going to distribute that negative sign. So minus 2x squared plus 6. So what is this? This is, how many x squareds do we have? I'm counting 3x squareds. Then how many x's do we have? We have 1x, and then we have minus 4 plus 6, so that's plus 2. So 3x squared plus x plus 2. That'd be your answer for that one. All right, 32. Solve the following equation. So I'm going to actually rewrite it up here. So 2x minus 5 times x plus 1 is equal to 3x plus 1. And then we're just going to solve this out. So let's distribute this negative 5 first. So negative 5 times x is negative 5x. Negative 5 times positive 1 would be minus 5. That's equal to 3x plus 1. Let's combine our like terms here. So 2x and negative 5x would make negative 3x minus 5 is equal to 3x plus 1. I personally kind of like having my x's be positive, so the easiest way to do that is to actually add 3x to both sides so that I end up with positive 6x on the right. So when I do that, I get negative 5 is equal to 6x plus 1. Then I'm going to subtract 1 on both sides so that I get, I'm running out of room here. Let's see, negative 6 is equal to 6x. And then if you divide by 6, you'll get that x must be negative 1. All right, 33. The school that Stephen goes to is selling tickets to a choral performance. Choral, whatever. Choir. On the first day of ticket sales, the school sold 3 senior tickets and 1 child ticket for $38. On the second day of ticket sales, the school sold 3 senior tickets and 2 child tickets for $52. Write the equations to represent X number of senior citizen tickets and Y number of child tickets. This is an absolutely terrible question. This question is worded horribly. I can't believe this was a past exam question. And why is that? Because X is not going to represent the number of senior citizen tickets. It's going to represent the cost of senior citizen tickets. And the Y is going to represent the cost of child tickets, right? Oh, that's going to bug me. All right. If you did 3 senior citizen tickets and 1 child ticket for $38, then you're going to have basically 3... Still on my highlighter. You're going to have 3X, right? X is the cost of a senior citizen ticket. And then 1Y, that's going to be $38. So 3X plus 1Y is $38. So instantly that's out. That's out. That's out. Well, that was quick. Let's just double check here. It also said that we sold 3 senior tickets and 2 student tickets for $52. So you should have 3 senior tickets plus 2 student tickets for $52. Yeah, so that's going to be A here. All right, that brings us to our last question on the multiple choice here. So find a value for m in the first table so that f of x is a function. Find a value for n in the second table, should say second table there, so that g of x is not a function. So we're going to find a number for m that would make f of x a function, but a number for n that would make g of x not a function. Well, what is a function? A lot of you have forgotten what a function is. A function is something where each input only gets paired up with one output. Okay? So what could we possibly put in here for m that would make it so that f of x is a function? Okay? Honestly, you can put in whatever you want for m, actually, as long as you don't put in -5 or 0. Let's think about this. If you plug in -5 here where the m is, then what are we saying? We're saying that -5 as an input has 2 different outputs. It has 2 as an output. It also has 7 as an output. That means it's not a function. So if you throw in -5 there, it would not be a function. If you throw in 0 here, it would not be a function, because that means that 0 would go to 7 and 0 would go to 4, not a function. Literally any other number that you put in here would work. Like if I put in 3 here, what would we have? We would have -5 as an input, has 2 as an output, 3 as an input, has 7 as an output, 0 as an input, has 4 as an output. Do we have any inputs that have the same or that have different outputs? No, so we would be good. Okay, so for m, anything, as long as m doesn't equal -5 and m does not equal 0, we're good. So notice how I'm doing an equal sign with a slash through it. That's what I'm saying. M is not equal to -5. M is not equal to 0. Anything in there in that range would work. Okay? All right. So we know instantly that A is out and D is out because M is -5 for A and M is 0 for D. So, all right. We would now need to put in a number for N so that this is not a function. So what do we need? We need to put in something for N that makes the same input number have different output numbers. So I would say n could either be like 9. If you make n 9, then what you've got is you've got 9 as an input has 8 as an output, and then 9 as an input has 0 as an output. So you have the same input number 9 with multiple different outputs. That is not a function. So either way, you could have n be 9, or you could have n be -3, just because you already have -3 down here, and -3 is supposed to go to 1, but if you have -3 going to 0, that would mean it's not a function. So we would need a situation where as long as m is not -5 or 0, and n is either 9 or -3, that would work. So I would say B is our option, our answer here. What's wrong with C as an answer choice? So C, the problem is if you have n is 0 for g of x, then that would still be a function, right? That would be okay.